Welcome, science fans. Today, we're diving into the world of energy, the power behind everything that moves, changes, or works. Think of energy as the go in a go-kart or the zing in a spring. In mechanical engineering, understanding energy is like having a secret decoder ring for how things work. There are two main types: potential energy, stored, ready to go, and kinetic energy, energy of motion. Every machine, from a seesaw to a roller coaster, is constantly trading between these two forms. Energy can't be created or destroyed. It just changes form, like a gift card being spent in different ways. Engineers choreograph this energy dance to make things work safely and efficiently. By the end of today, you'll spot this energy exchange everywhere you look. Let's get started. Let's talk kinetic energy, the energy of motion. If something's moving, it has kinetic energy. The faster or heavier it is, the more kinetic energy it has. The formula is Ke L 1/2 mv2. M is mass, V is velocity, speed. Speed matters a lot. Double the speed and kinetic energy quadruples. Think of a bowling ball versus a ping pong ball rolling at the same speed. The bowling ball packs way more punch. Cars on highways, wind-turning turbines, even you running to class, all are examples of kinetic energy in action. Engineers use this knowledge to design rockets, brakes, and more. Kinetic energy is what makes things go, from meteors to ants. Understanding it helps us create and control motion in the world around us. It's everywhere. Now, let's flip the coin to potential energy, the energy of waiting. It's stored energy, ready to be released, like an apple on a branch or a stretched rubber band. The most common type is gravitational potential energy, PE equals mgh. Mass x, gravity x, height. The higher and heavier something is, the more potential energy it has. A dam holding back water is like a giant battery, full of potential energy. A book on a shelf, a spring ready to snap, or a drawn bow, all store potential energy. Elastic potential energy is stored when you stretch or compress objects. Release it, and it transforms into kinetic energy, like a flying arrow. This principle powers everything from car suspensions to retractable pens. Potential energy is everywhere, just waiting to spring into action. Here's the magic. Kinetic and potential energy constantly swap places. Picture a swinging pendulum at the top. It's all potential. As it swings down, that turns into kinetic energy. At the bottom, it's moving fastest, maximum kinetic, minimum potential. Then it swings back up, trading kinetic for potential again. In a dam, water's potential energy becomes kinetic as it falls, spinning turbines to make electricity. Roller coasters climb high, potential, then race down, kinetic, thrilling us with every energy swap. This back and forth is the engine behind countless machines and natural wonders. Engineers harness these conversions to power our world. The total energy stays the same. It just changes form. That's the beautiful dance of physics in action. Why does all this matter? For engineers, mastering energy is everything. They design systems to manage energy efficiently and safely, from cars to wind turbines. Real-world energy conversions aren't perfect. Some is lost as heat or sound. Engineers work to minimize these losses, making machines more sustainable and cost-effective. Safety matters too. Crumple zones and brakes use energy principles to protect us. From toys to power plants, engineering is about putting energy to work for humanity. By understanding potential and kinetic energy, engineers innovate and solve real problems. Next time you see something move, remember the energy journey behind it. Science is everywhere.